Welcome, ladies and gentlemen, to Neo Tokyo's official podcast, Interlinked. Huge shout out to our sponsor, Playa3ull Games. They are inspired by gamers and funded by their community. They have a epic game on the Epic Games Store, a third-person shooter called Nexus. Hop on in there and check that out. They're also currently selling nodes, so if you're interested, check that out at their website, playable.games. That is a 3 instead of a B on Playable. Now strap in for the rest of this episode of Interlink. I'm joined today by John, one of the founders of Beamable. How are we doing today, John?
Awesome. A little tired, but cranking along. Thanks for having me.
Well, I appreciate you making the time. I know it's a full tilt week, which we'll be getting into all the stuff that you got coming down the horizon. But maybe we get started on your background. What brought you to this crazy sort of Web3 gaming infrastructure space that we have?
Yeah, well, my background is in two major categories. One is I started a web development tools company. It was called ePrize, brought it public on NASDAQ, grew it to 300 people. So I've been down that path. And then I did something completely different, probably because I was slightly crazy, but loved games. So I started a game studio. So I started a studio called Disruptor Beam, and we shipped games based on entertainment franchises like Game of Thrones, Star Trek, Walking Dead, Archer. So ship games to 20 million people, mobile, free to play, PC games, and one crypto game. So we took Star Trek and we built a blockchain version of it, minted 1 million wallets in one of the early gaming chains. So that's sort of the main background, but about 5 years ago, decided to solve a lot of problems in the game industry around just building your game, getting it to market, because the big bottleneck had been servers, right? The front end, where the graphics and things like that occur, there had been game engines for a few years at that point, Unreal Engine, Unity, and so forth. And those engines had solved an enormous number of problems for developers because it saved them the trouble of essentially building their own 3D tech so they could focus on the fun. But they were still building game servers. They were still building all this complicated, scalable cloud tech. And that's where I thought I could help because I'd also had that development background. So started that about 5 years ago and have been at that ever since.
Yeah, I'd love to linger on sort of one part of your background. Like, obviously, those are massive, massive IPs that you were working with. So how'd you go from obviously having a successful track record on the NASDAQ is a nice like feather in your cap for those pitches. And I'm sure that's something that, when people were trusting the IP, they're like, okay, well, clearly this guy can execute and has executed. But how'd you go from launching a small gaming studio to locking down some of the biggest IP that's either ever existed or at Game of Thrones? I mean, it was absolutely massive in its heyday.
Uh, a lot of entrepreneurial hustle and a lot of patience. When I first went after Game of Thrones, I think it took me like 2 years to get an audience with George R. R. Martin. Really just had to like pursue his agent for a really long time. Actually, I was kind of an idiot about it, to tell you the truth. Like I knew that I wanted to do licensed IP because I saw that as an opportunity on mobile. At the time, no one was doing licensed games, so would it be new? And I wanted to kind of rise above the noise of a lot of the mobile games that were happening. And a friend introduced me um, to an agent who worked out in Hollywood and kind of worked with a lot of like science fiction and fantasy authors. And I had the initial call with this guy, and he asked like, okay, well, I work with a lot of authors. Like, who would your ideal one be? And I was like, well, I really like Game of Thrones. I think that would be a good IP for a game. And he just sort of reacted like, okay, yeah. And it was only like later that I learned he was George R. R. Martin's agent. So he probably thought I was fishing for that specifically, even though I was just dreaming. Anyway, it took a while, but eventually got in front of George R. R. Martin, and he really loved the idea that we had for the game, and we took it from there.
Well, I certainly hope that that's an IP that clearly they're creating a lot of like spin-off like branches for the television series. Um, but I'd love to have that world explored a little bit more in game form. Like I was such a big fan of Shadow of War and Shadow of Mordor. So to imagine like some sort of like game where, I mean, there's just so many different aspects. You could have an RPG based on like the wall, and you're like a scout for, who's taken the black and is going out into the north of the wall to do scouting missions. You could like work for the Faceless Brotherhood. There's probably a pirate game that you could sneak into offshore of Westeros. So I certainly hope that he continues to explore bringing that to form in game.
He built a huge world, so I you certainly could explore all these corners of things. And that's kind of what we actually did in the game, because in the game we created, which is called Game of Thrones Ascent, it wasn't about playing like Jaime Lannister or something like that. It was about being a noble lord in that world who was not one of the main characters that you sort of read along with. You'd interact with them, it would be part of the story. So all those things would be happening, but you were kind of creating your own story in that universe and bringing it to life and also interacting with other people in that universe. So we we built it kind of with some of the thinking that you have in mind, where you're exploring the pieces that were not directly addressed in the book. We launched it at a time where everyone was creating this genre called social games. I mean, of course, almost all games are social to some respect, but what they meant was games running on social networks like Facebook in the early days. And what I told George that I think won him over is everybody's killing everything, each other in your books. So we should just make this an anti-social game. I don't know. I think that stuck in his mind and he liked it. And I remember when I showed him the first build of the game, he was sort of, his reaction was the game looks good, but people aren't dying enough. Can you make like die? So we had to go and like make it a little bit more deadly, but without making people feel like they were going to rage quit out when bad things happen. So that was a lot of fun to work with. George was amazing. He's a genius. He is not a computer person at all. When I met him, he was working on like a PC from the 90s, right? Like WordStar was what his word processor. But that said, like that makes it sound like he's going to be, like not up to speed with everything technology. That's not true. He was very sharp in terms of like understanding how the game would work and how it would work within these communities. So I give him a ton of credit. It was one of the most fun things I ever worked on for sure.
Yeah, and I think we're going to see just constant waves of like IP based game development, because as these like tools get better and better, and the barriers of like building great games either through tools like excuse me, the ones that you're building, or AI based like tools, although they are in their primitive stage, like eventually like so many games are going to be so technically good and probably like fun, that I think one of the big differentiators is like, do you have like IP that people are going to be really excited about?
hmm Yeah, I mean, and that's an interesting idea because the problem with there are also problems with IP when you build a game like we did for like the very top tier IP like Game of Thrones. It's hard to make games for I'll just call them like more niche audiences. And when I talk about niche, I mean like stuff that millions of people like, which doesn't sound niche, but when you talk about like global mega brands from like a Game of Thrones to a Star Wars, Star Trek, things like that, like they're kind of a class unto themselves. So it's hard to build a game based on like a quote unquote niche audience of a few million people. But when you democratize the tools and make it much more accessible to people, then you're actually able to do that because you can have a smaller team, it's less capital. In fact, I think this is a lot of where the future goes. Like a preview of the future for game development is a lot closer to what we see happening on Roblox, for example. Now, I think there's a ton of things you could do better on Roblox. You could have a better 3D engine or just choose your own, like just bring Unreal Engine or Unity to the party and like have the multiplayer coordination, the social systems, all of that baked in. That was kind of the original idea for Beamable, by the way, which is we wanted to think in terms of how do you give people all that power that you see in a platform like a Roblox and the ability for a much smaller team or even just an individual person to deliver the vision that they have for a game, but do it in a more decentralized way where they can pick the main pieces that they want. So our idea was we'll give you the whole back end social platform and it can run anywhere. And then you pull the game engine that you want, Unity, Unreal, web browser based, put it on top. and you focus on the fun. You deliver it with the visuals and the experience you want, all the social apparatus, the payment systems, the multiplayer coordination. Like that's just automated in us. So that was kind of the original idea. And that's where I think the market is still going, especially when you start applying these new techs around stuff like vibe coding or just things that help smaller and smaller teams build stuff, generative AI and whatnot, and just off the shelf tooling. So we'll get to a place where, the game that has an IP in it that millions of people know, or hundreds of thousands, or maybe just even thousands, or maybe it even eventually gets to the point where it's like being a dungeon master. Like you could just make a game for you and your friends, and it's really awesome, and you go and hang out there together, and it's a terrific experience. So, like, I really just believe that gaming is the media category of our time, and we want to just put that power in the hands of everybody who's got an idea to be creative through this media.
And my hope with that transition is it'll be like a bit of a renaissance for gaming because games had become so unbelievably like bloated compared to what they had been, just a period of time ago. Where you look at like where Doom came from and the amount of people that was working on Doom. Now, not every team's going to have
Great.
a John Carmack.
Yeah.
But when you get these and you saw it kind of in movies, when games become like focus group to death because you put, sort of billions of dollars into it or hundreds of millions, and you really can't afford for that to resonate with 2% of the population. But then you don't get things like Boondock Saints, for instance, which, resonated with such a little like cult community and was something special, but was never going to be like mainstream. So my hope is now that these tools are getting better and better that, small, super passionate like groups of gamers. I think Stardew Valley might be a good example of that. Like that was I think one person's like sole project.
Mhm.
And that game's freaking awesome, especially from, an old lover of like the Harvest Moon series. That was, something special. So I'm hoping that we're going to see more of that in gaming, more of that in TV and movies.
I mean, I think Stardew Valley is a great example, though, where you really can build a super fun game with way smaller than the teams that are currently used in like typical mainstream game development. And they're not totally unique. You've got games like Undertale. That was one guy literally did everything. More recently, even got like Hollow Knight, like they've kept that team really lean. I think it's 3 or 4 developers on the team there. So, like, you can do it, but it's hard. The reason they can do it is because there has been more and more tech available to actually build around. So 3D engines have helped a lot, and more off-the-shelf components that people could bring in. The whole development of open source culture, like it would be like in the case of Stardew Valley, he basically made his own game engine too. Like to get to that point without the availability of open source software would also be really, really challenging. So that's kind of where we're going with Beamable, though, is fill in a lot of those big, huge holes, and some of the ones that are the most risky too. When you talk about back end infrastructure, you're talking about compute. You're talking about being able to access servers and scale up to lots and lots of users. Because that's the hope of any game developer. You hope that millions of people end up playing your game, but if it falls over instantly, you may never even get there. Or be an Among Us for that matter. Also, a very small team that built that. Like for a year, their DAU is in the thousands. And suddenly, when streaming culture caught it, it went to, I think they had like 160 million MAU at one point, like insane, insane numbers. Fortunately, kind of a peer-to-peer technology, or it would have been really hard to scale up for that. But to have a back end that has shared worlds and things like that, you really need to be able to have that thing scale. Could you imagine if suddenly there was that demand for your game and you didn't have the ability to capture it? Probably once in a lifetime opportunity for a lot of game developers. So, and frankly, like that stuff's kind of boring to build if you're a game developer. We think it's cool because we get to build it for like super high scale for everybody. Like that's a little bit different. But when you're a game developer building a game, you don't want to be building like user account login systems and like payment rails. Like that stuff just got to be drag and drop in the game engine, added in easily. And that's what we've built at Beamable.
Yeah, and it's really like, from my perspective, kind of getting gaming development to where we got content creation with like social media. Like you don't need any technical skills. You don't need to worry about servers. If you're creating YouTube content or streaming on Twitch, like you don't have to worry about any of that. You just have to focus on, putting a finger on the pulse of what people want to listen to and creating great content. And gaming's been so technologically intensive in a bunch of different like aspects that I'm such a big advocate for the lower you can get those barriers, the more creativity you're going to see. But
Yeah.
maybe to like, bridge our way into like the beamable focus portion of the conversation, maybe we do a little bit of a snapshot, like how things were, what was the status quo of how people were doing like kind of their server development, to what they can now do utilizing beamable.
Well, in the past, people were spending millions of dollars building game server tech. And sometimes you could start small for sure. You could write a few lines of code that's your server, but it always grows. And then you have to address scaling issues. And then the real complexity comes into workflow. Like, how do you just make it work with your game engine? How do you make it easy day to day? How do you debug it? Like, that's the real complexity of building platforms. And when you build it yourself, what you do is you're building technical debt over time that then starts taxing you, and then that tax crowds out your ability to do all the things that is a fun for you as a developer, but more importantly, the fun part that your players actually care about because they're going to want to be able to play a fun game. And if you look at last year on Steam, there were 19,000 games shipped. This year, there's probably 25,000 games shipped on Steam. Like, if you're not one of the most fun games on Steam, it's going to be really hard to stand out. So, I'm just a big believer in accelerating development velocity and within that velocity, focusing your time on the things that actually matter to people, which is the fun game. And we have an infrastructure that over 100 games have now trusted for their game launches and have scaled way up, like some pretty significant, numbers on some of our games. Last month we had 2.5 million users playing the games on the network. So we have done that so that you don't have to worry about it as a game developer, and you get all this off the shelf game servers, multiplayer orchestration, data persistence, account login, payment rails, social systems, chat, tournaments, events, like the list goes on and on of like the off the shelf stuff. And it works within the game engine that you've already got. So you don't have to build a bunch of middleware and patch it all together. It's like just sitting down in front of the game engines that you already use, Unity, Unreal, web browser games. You just add that capability in.
Oh, that's great. So to like, and I think servers are sort of more on people's mind in this month than they have been, as like Amazon
Wonder
had
why.
its big hiccup.
Yeah.
Um,
More than once. Yet, I mean, that was last week. And then AWS and Azure went down just a couple days ago. So this keeps happening.
Yeah, and it's like something like the average homeowner doesn't know anything about how their HVAC works until it breaks, and then they're, quickly becoming an HVAC expert through talking with whatever vendors at their house. So, out of curiosity, first is how was y'all's platform affected, if at all, by sort of like Amazon and Azure like going down?
Well, we did really well. We didn't go down because we were already distributed over multiple data over different data centers than AWS had trouble with. But I think you're still pointing at a core problem that is the next stage of our evolution as a company that we really want to solve. And that's that, just generally speaking, the computers that run everything on the internet are largely running at three places: Microsoft Azure, Amazon Web Services, and Google Cloud Platform. That plus Meta actually, just speaking to the numbers, that's most of the computers of the internet, believe it or not. So that's an awful lot of centralized risk. So we're talking here to a pretty crypto native audience. Guess what? A lot of the layer twos on Ethereum actually went down because it turned out that so many of them run on AWS that, as much as they talked about decentralization, wasn't really decentralized. There was a single point of failure. Good exception to that, Solana went through it fine because they've got so many data centers out there. So this is the change that we want to bring to compute generally. So we've had this vision for a bit, which is, compute shouldn't just be locked up inside a few companies where you sign contracts, have single points of failure, closed proprietary ecosystems. What if you could just free that compute and make it more fundamental to the internet, make it compute power that could be streamed to any variety of applications? And of course, games are a huge user of that because games have to scale up and scale down. And we have all these customers in games. We're launching new games all the time. So we had the ability to really tap into that compute. But of course, we saw a much bigger problem too. We saw the opportunity to solve just a general compute problem on the internet and really turn it into an asset class. So, simple comparison, energy. If you put a solar panel on your house, you typically can sell that energy back to the grid. And that's because we have a market for energy. It's not that way with compute, right? Just attaching your computer to the internet, there's a couple of ways you can participate in certain kinds of projects that work together, but generally speaking, you can't just provide generalized compute back to the internet so that other people can consume it. So we started to have this idea that we've come to call compute capital markets, where let's take that compute that computers are offering, use technologies that we've already got available for subdividing it into little chunks, but wrap it in an asset structure using blockchain, where that is what actually facilitates turning it into an asset, which now it's tradable, streamable, it's peer to peer. You can use it in your application. If one of the providers that you're using goes down, it's a more of a rerouting problem to a different provider than it is you wait for that one point of failure to fix itself. And also, we use market forces for pricing. So instead of, oligopoly economics, you have the ability to have an order book where people that offer compute say what price they want to sell it at. And similarly, people can just set a limit order and say, here's what I'm willing to pay for compute. And then you match make it and you reach market equilibrium and supply and demand match. That's sort of the vision that we had. And, our foothold, of course, is gaming. And I think one of our competitive advantages in bringing this idea of compute capital markets to the internet is that we've got so much strength in this vertical where we really know how to sell into that market. We've got a lot of experience onboarding that demand. We're trusted by game developers. We're shipping more and more. So that'll keep growing and growing within this architecture. But then we have this opportunity not only to add resilience, better costs, et cetera, to the gaming market, but everybody else. Like there's a ton of internet applications that use what we call containerized compute or microservices. And we can make a platform that just turns that into this asset class that's tradable, liquid, streamable with no single point of failure on the network. And that's what we're going to next with Beamable. That's Beamable Network, which we launched that, let's see, yeah, Thursday next week, 6 days.
Nice. And by the time people are listening to this, that should be tomorrow. So it'll be coming up even sooner.
I should have thought of that. But yeah,
No sweat. No
Thursday the
sweat.
6th is the
We're
date.
living in the past.
Thursday,
Well,
November 6th.
well, like the commoditization of assets or like of energy is something like I've always found like very fascinating, especially since getting into like sort of like Bitcoin and gold. One of the interesting things about both those sort of commodities is, one sat is one sat. 1 ounce of gold is 1 ounce of gold. You can get into nuances as long as you trust wherever the gold is coming in, because you could have purity issues. Now, is there like what is the like for gold it would be weight, for Bitcoin it would be sats. What is like the denominator for energy and or for compute? And is the compute at a place where 1 unit of compute is 1 unit of compute, or is there like quality in between like the different types of commute?
That is a superb question. So let me kind of drill into how we're thinking about it and I'll also talk to maybe where we go in the future of our roadmap. So energy analogy, solar panel, you get it's kilowatt hours, right? So that's a global currency essentially that can be traded for whatever it is in your local market. With compute, of course, it's different because there's a zillion different computers and different kinds of applications, CPUs, et cetera. So for us at launch, what we have is the idea of an API call, which is an average of a small unit of compute. There is actually variability in how much compute cycle is associated with any one API call, but we use an averaging to figure out like what is this small quanta of work across the network. So just to give you a sense of it, the last month on the network, we had close to 100 games live, 2.5 million users. The 2.5 million users generated over 10 billion API calls. So that API call is what we currently use as that small fractional component of work, which we average out over the network. So when we structure the order book around that, basically people are saying, this is what the average API call costs on my machine because you're not serving like one exact kind of API call. It's still averaged across a lot of different users. It's multi-tenanted, and even there's lots of API calls across any one particular customer that's using it. So you price the API call, and that's how we quantize that for the use of the users, and that's what you're pricing. And that's actually how we currently price on Beamable. So like the SaaS version of Beamable, where people come in and they buy packages of API calls, that's what they do. They're buying the bundle of it and using it for a variety of purposes. So it makes an easy transition to what we call a DPIN or a decentralized physical infrastructure network. So, over time, though, there are going to be other variables in play, and we think that there's even better ways of quantizing that performance based on, relative like CPU cycles and things like that. That's in our roadmap to get there down the road. That's going to be like, if you want to really look at like what's the R&D work of Beamable going forward, it is the marketplace economy. It's taking that protocol, figuring out other mechanisms that really get us to market optimal pricing of these discrete units of compute, accounting for them, and whatnot. You mentioned some other variables that are important too, though. So when you think of the market economy for compute, one variable is the quantity of compute. There's another, which is a quality function, like how reliable is the source of compute that you're going after, and what's the latency, right? Because you're typically dealing with distance between a user and the server that addresses their particular needs. So the market economy in the order book also has to account for different classes of compute based on that as well, because many applications and games are a great example of this. So for some games, latency doesn't matter too much. Like takes a few hundred milliseconds to respond to your turn-based game, most users aren't going to notice, but you really notice in a MOBA or a first-person shooter or things like that. So there, the latency variable ends up becoming important. So what you're effectively bidding on as a user of that compute is not just the amount of compute, but a latency variable that you want to be able to rely upon. So that's a big part of our roadmap is things like that, online reputation, on-chain reputation, SLAs, what we call service level arrangements or service level agreements, all the things that people actually care about when deciding on the kind of compute. And actually, sometimes, for example, you want lower latency compute. You want the quote unquote lower quality compute because it could be lower cost. And for certain kinds of applications, if you don't need the super high latency, you should actually be paying less. Because again, this is really about converging market forces, making sure that the demand and the characteristics you actually need for your compute match what is being delivered to you, and that it's essentially reaching market equilibrium pricing for the kind of compute you need. So that compute capital markets idea became this thing that really drove us to the launch that we're doing because that's what we're building. We're building a compute capital market, and we're really starting with this strong foothold that we've got in games where it's our gaming backend that is auto deployed on the network. Anybody can spin them up. But we're building out a whole ecosystem. And that's everything from game developers and game tech that can be added to the servers that we're operating on the network. But then everything adjacent. You start to unlock things like, you know, e-commerce and website operations and virtually everything that requires CPU will be suited to this network. And that's what we're really excited to scale because I think that a compute capital network just totally transforms the way we provision this capability currently because it's locked up, it goes down, it's pretty expensive. And while those companies have definitely solved a lot of problems, it was better than what we had before, which was build your own data center, was the previous solution. But now we want to go from oligopoly to a market and a market that's peer to peer. And that's going to be transformative for how people build anything on the internet.
Now a word from our sponsors.
What's up, crypto gamers? Shout out to our sponsor, Myria. Myria is revolutionizing Ethereum-based gaming with its powerful L2 scaling solution. Think zero gas fees, instant transactions, free NFT minting, and more. Myria offers a suite of tools that are tailor-built for game development, including game-specific SDKs, a spec'd-out marketplace, Web3 spiked leaderboards, new AI super tools, and more. All this fueled by a fleet of player-run nodes that are a breeze to operate and pump out daily rewards for supporting the ecosystem. Plus, check out Meta Rush, the Battle Royale obstacle runner by Myria Studios, dropping very, very soon.
Now back to your regularly scheduled program.
And I have to imagine the DPIN, with the current limitations we have around latency being fastest you can get is fiber. I don't know if we're going to see, I mean, humans are constantly surprising each other, so things are possible. But based on my primitive understanding of fiber, it's sort of dictated and limited by the speed of light that's running through those cables. So unless we figure out a way to transmit data faster than light, big if, it essentially requires DPIN in order to get latency down to levels that would not be feasible unless you're sitting outside of the Atlanta data center or you're doing all of your gaming in the desert of Nevada. So because I have to imagine that by me accessing, my neighbor's maybe server, for instance, like I'm going to be able to get a lower latency if that's important to me. So maybe you can touch upon how sort of like DPIN sort of like fixes that.
Geographic distribution is one of the things that really favors DPIN because what you've done is you've created these token incentives for people to bootstrap more and more nodes to the network in response to the demand. The key is to have the demand, though. Like that's, again, going back to our advantages. We have all of this built-in demand to the network. You've got all these DPIN projects running around just putting supply online without the existence of any demand that can utilize it. We think you lead with demand and then the supply follows that because there's always suppliers that are willing to capture that demand and we can help facilitate it. But yes, one of the really interesting things about DPIN is instead of having a few data centers around the world owned by one big company, instead you start to actually create a lot of incentives for smaller data centers, more localized data centers, and much more geographic distribution because you solve the kind of the coordination, the trust problems, the ability to bring all these different cooperating participants in the network into a market. And the market becomes the cooperation mechanism instead of contracts and silos and things like we have now.
It's going to be interesting to see how the big hyperscaling players like react to this. One, I wish I could remember the people who are launching it or the name of the company, but one of the big things I came across recently in energy was this plan to essentially build out battery banks at a bunch of different homes so that you can store energy when it's cheap and essentially have like a large network deep in for energy sort of like structure. So I do wonder if there's a future where similar to getting like a Tesla battery wall that you can maybe get free internet, maybe get discounted internet, discounted Amazon services. Hey, free Prime if you set up one of our, server racks for your internet instead of using like a conventional model. So it'll be interesting to see, especially Amazon, since they already have the distribution sort of infrastructure for physical goods as opposed to like Azure really mostly Microsoft has focused on like digital delivery. I think it'll be interesting to see how the hyperscalers react. I don't know. Have you played that sort of like mental
I think they're all
simulation
going to,
out?
yeah, I mean, I think they'll all be part of it. I mean, they're some of the best suited companies to be part of that market economy. So of course they will. So as we build out our decentralized physical infrastructure network, it's not, yes, on the one hand, it competes with the hyperscaler business model, but also hyperscalers can take any of their underutilized or unused capacity that they've got and offer it to that network as well. So it's just as much an opportunity for them. Now, long term, it may erode some of their margin and to go back to Jeff Bezos's famous saying, your margin is my opportunity. Well, cloud service providers have incredible margins. Like Amazon, the company as it is today, is largely built by all the margin contribution from AWS. So if we have a market economy, you're going to naturally have much more convergence between pricing and the underlying CapEx and energy cost that the data center operators have, which will be good for everybody actually, because there will be other market participants that can access more customers. It's really hard for bare metal service providers or data center operators to access the global market for compute. They kind of have to go and find long-term clients that want to lease and kind of be co-located. Like that's a lot of work and a lot of expense to do that. If they can just offer compute, they can actually access far more customers. So it's good for them. And the customer, it's great for them because the pricing is typically better when they're able to tap in to those kinds of supply. But of course, the hyperscalers with their millions of servers are going to be part of this market as well, and they'll offer that supply, and that's great, I think.
Yeah, and plus you got to imagine that more and more supply is going to come online just by the fact that technology just keeps getting stronger and stronger from a mobile standpoint, from a headset standpoint, from smart glasses. How many Teslas are sitting using a fraction of their GPU because they're parked in at work. So you got to imagine as this sort of advances, there's just going to be little nodes everywhere where maybe you click in the T's and C's that, hey, when your Tesla's not working, it's actually providing, it's either providing that energy on the free market to sort of subsidize some of these electronics. And then, if there's going to be a revenue generating opportunity in these electronics, you can put more development into there because, it's not sort of just like, hey, we're selling you a $5,000 phone. Hey, we're selling you a $5,000 phone, but you're going to get paid each month as opposed to, paying, however it ends up getting structured.
Yeah, I mean, it's Airbnb for your computers. It's make it available to people who need to use it. The difference versus Airbnb, at least for our model, is compute can actually be a bit of a fungible resource because it's possible to subdivide compute down into little components. And we don't need to go super deep on like the tech that enables that, but there's things called in the case of Amazon, they have something called lambdas. In the case of Microsoft Azure, they have something called Microsoft functions. And the idea is have these little units of compute that can then be thrown at lots and lots of servers to meet very high levels of demand. Like suddenly you need 1,000 servers that can run the same function over and over again for lots and lots of users. That's something that hyperscalers do. So you can do that with a big aggregate network of compute operators and suppliers as well. The difference is the computer that's offering that supply, they can actually service that demand for lots of different clients. It's not like you lease that computer and you're renting it like an Airbnb, literally from one person and then leave it, at least in our model. There's other people actually that are doing that model on DeepIn. For us, it's more about the fungible compute aspects, the ability to access scalable up and down demand for functional components of software. And that means everything's multi-tenanted and the computer actually can be used a lot more because you can imagine in like the lease a computer model, the rent something on the rack model. Well, you've rented it. All the time you're renting it that you're not using it for yourself is actually wasted. So this ends up being actually much more efficient for everybody. You get to use that compute capability across many, many users to maximize the value of that asset. And that's all about, that comes just back to this idea of compute capital markets. And really figuring out how you structure compute as an asset class, use convergent forces for pricing and maximum utilization to create an efficient market for it. And what we know from the history of anytime you decrease the cost and the efficiency of a technology product, you then inevitably unlock an enormous number of new use cases that weren't even possible before because you drop one of the big constraints, which is cost. And this can kind of bring us all the way back to kind of what we were talking about originally, like game developers. How do you unlock all this creativity amongst game developers and start having more types of games? Well, a way that you could do that is drop the cost so low that individual people can suddenly enter this market, put online multiplayer massive worlds together as a one person show, and you're going to see a lot more options there. And by the way, that person doesn't have to have a game that ships 10 million copies to even turn a profit. They might be just happy to do it as a hobby, for example, and it'll be really fun. Or they'll do it as a full-time gig for themselves and have, I don't know, a few thousand customers who love it and they're all the time. So I think that the business of all kinds of applications, games, software, e-commerce, like you open up this whole possibility space anytime you can really compress the underlying cost constraints that allow people to enter the business. And online internet compute capacity is one of those huge costs that both prevents people from doing it just from a pure compute, like it costs money just to access a computer and use it for its compute cycles, but also all the work of building up the software around it, designing your own servers, writing those lines of code. Typically, people are just doing this stuff over and over and over again. Even relatively simple applications, there's always just customization. So when you standardize it, you're also increasing interoperability. Interoperability leads to ecosystems where lots of people are building on top of it. You're effectively crowdsourcing innovation out to a community of people that want to add things on a shared backplane for payments and data languages and such. So yeah, I'm excited about like figuring out how we go from software that's APIs in silos with contracts to protocols and markets and a lot of resilience, lower cost to unlock creativity and capability.
Yeah, let's dive into the economics portion. So, I guess from the like end user of these units of compute, I imagine it's relatively simple. You had described like sort of an API based like breakdown. So you're paying for, I've got a game, I'm paying for X amount of like API to utilize the network. Correct me if I'm off on any of that, but I'd be interested in diving into the DPIN side where how do the economics work for the people that are contributing to the network?
So so there's sort of two versions of that. One is people who offer compute. So you can operate a worker node and then you're just supplying compute back to the network. So they price their compute however they want, and it's priced in API units, API call units. So you say this is what I want to price it, and then anyone who is willing to pay that much that can be matched to you through the order book gets that compute supplied to them. That's pretty straightforward. And the way the protocol works is whatever that price is, that's what you receive. Okay. What's added to that is a network fee at the protocol level, and it's 2% if you're paying in native tokens. We want that as an incentive to keep the cost super low. If you want to use network token, if you want to pay in stables, then it's 15 to 20%. But then what we do is we use any stable payments as a source of repurchasing tokens. So like we're getting a little bit into token design here as well, but like basic idea is the more and more usage happens on the network as it scales out the number of API calls, the actual compute, which is what people are paying for, the more revenue it's generating, the more of a deflationary token it becomes because you're taking token off the market. So we're trying to keep things relatively simple to understand. Revenue goes up, token goes down, like everybody wins across the board over the life cycle of this thing. So yes, sort of like what are the other contributors? So You can contribute compute, which is what I just described. Another thing you can do is you can operate what's called a checker node. So to operate a worker node, you really need data center grade capacity. But if you want to be involved like at the retail level and find the underutilized ETH rig that's like gathering dust in the basement, you want to have it just run a checker node, that'll be fine. Actually, if you had a Raspberry Pi, that would be fine for running a checker node. And they do important work in a decentralized network is they're verifying transactions. They're making sure that the worker nodes actually did what they are reporting that they did. They look on chain to see that essentially supply and demand matched appropriate and was delivered and measure quality. And they have to approve the release of payment to the worker node. So that's what checker nodes do. That's another thing that you could add to the network. Another thing that you could do is add software to the network. So Beamable has its own software for game developers. You could either target game developers, add features for them, or you could even do something outside gaming. Like we envision this as a generalized network for any kind of software application that needs to scale up with a lot of servers. That's where our marketplace vision comes in because one of the things that we realize is once you have the physical infrastructure in place, the servers you can provision capacity off of, well, the next step is why not open that up? Because you've already got the payment rails in place for the use of compute. Let people put their software modules on there as well and say, here's the license fee that it costs to use it on the network, or here's a royalty that I'll charge on top of the underlying compute. And again, name your own business model. They choose whatever they want. And you now create a software marketplace on top of the DPIN. So that's another way that people can contribute. And we think that people will be happy to do that when the alternative is build software as one-offs that you never really even get paid for proprietary ecosystems. So we're just trying to open it up so that you really get that innovation and creativity on the back end of software development.
Then one question that popped in my head is, will the API amounts be charged in something that's like pegged to like USD, or will it be pegged in sort of like a fraction of y'all's token, if that makes sense?
Yeah, so we believe the worker nodes can price it in either. So if they prefer to get paid in token, they can have token-based pricing. We think that the vast majority of worker nodes are going to price in stables, even if payment is made in native token. And that's just because if you operate a worker node, at least in today's world, you've got energy costs, the computers cost you something. Usually all those payments are structured in stables, and you need to be able to figure out what your margin is going to be on offering that. There'll be some people who play the volatility game because there's more upside associated with it in theory, but then you have a lot of hedging risks and things that you got to kind of account for in there. But we think that most people probably do price in stables as far as the compute provisioning is concerned. But we give people the option to do either. And the same on the payment side. If you want to pay in stables, that's great. Like we use that to repurchase native token, which is great for everybody up and down the kind of the value chain of operating it. And if you want to pay in native token, that's great too, because that drives kind of the whole flywheel of the token itself. And we want kind of the token continuously flowing through the economy.
And then as far as like in a DPIN network, I imagine like routing is super important. Is that handled by the work nodes or the checker nodes, or the software itself that you guys are deploying?
Yeah, it's a great question. There's actually a third node type. We're just not ready to roll that out initially, which are router nodes, and they operate effectively as the API gateway that help determine the routing. In the initial implementation, router nodes and worker nodes are kind of the same thing in our architecture, or at least kind of glued pretty close together. But over the next year, we'll separate that off so that router nodes operate independently so that they then figure out, well, what is the best worker node in the network to connect you to.
Yeah, because I imagine that'll bring in like sort of like a whole new player who specializes in like, sort of like the logistic companies that like do shipping. Like there's someone who sits in there and is like, hey, I actually realized I can cut our costs X amount if we, bing off this data center to go and hit this little like ETH rig that's sitting doing nowhere or doing nothing. So I think that'll be just another time to bring in like sort of the market forces to find inefficiencies in exchange for profit.
Yeah, that's right. I mean, you're pointing at all the right things, which basically comes down to what are the factors that go into a market economy for this. One is what is the, what is the cost of compute, which is driven by underlying OpEx, CapEx. And that's why in our model for the protocol, we had lots of ideas around it. One was, well, let's just the one we didn't go with was here's a unit of compute, here's how many beamable tokens that costs. The problem with that is it becomes a nightmare in terms of really letting the worker nodes figure out what their internalized costs are. Because the fact is, if you run a data center that's all off solar panels in the middle of the desert in a low cost environment, then your costs are very different than someone who's on a power grid in New York City, for example. So that just kind of drove us more and more towards like a true market economy for it, where you try to let the people who are closest to costs and decisions, they just kind of know best for themselves. So there you have the worker node saying, well, I'm going to supply a worker node and it supplies compute to the network, but I know best what that compute costs me to provide, so I'll just price it. And that's why you end up with an order book.
Got it. Now, I actually had some like kind of Web3 based questions, but before I ask those, are we missing anything as far as like the tokenomics or anything else about the token that you want to cover? Obviously, that's going to be in the forefront of a lot of people's minds as this will be coming out right before that.
Yeah, I mean, we're launching the token. We're selling some tokens on November 6th, and then we're gonna a few days later, we're gonna open it up at the TGE. What can we say about the token? So the first of all, the token is just it's a utility token that's used for payment on the network, number one. So the token is used to provision compute capacity is kind of the basic use of it. It's used for other things like staking on the network, because when you have a decentralized network, staking becomes something that you can use to de-incentivize cheating. So we'll slash people's stake if they like hack a worker node and try to have it report on-chain transactions for work that they didn't do. It's used for governance. We want to really have a community culture around the protocol where improvements to the protocol are proposed by the community and go through a governance process. So governance is going to be part of it. It's used for the ecosystem development, such as the software modules. Again, also as a payment instrument for the software modules. And it's used as an incentive mechanism for node operators to join the network and be there and not only offer compute, but special incentives just for being available. For example, like we don't want nodes that come on and off the network constantly. We want you to be there. If you're there, you get bonus incentives for just participating. So those are kind of many of the uses of the token out of the gate. And I think the most important thing to understand about how we're approaching this protocol is a lot of thought into the alignment of what's important from a quote unquote business standpoint of the protocol and then aligning it to value accrual in the token. So the way we're approaching that really just comes down to the KPI for the business is how much does it get used and how much are people paying? And the more people are paying, it's basically revenue to the protocol. And the network fees drive the ability to remove from circulation tokens through buybacks. And if you look at deflationary tokens, that's the way to really drive value. And think of it more as like a token GDP more than anything else. It's more than a market cap, it's a GDP that like the token represents a piece of the overall circulating use of the network and the utilization and the revenue transactions that are happening on it.
Yeah, and I think it'll be interesting to see how companies either like hoard the token because of the fact that they are expecting the buybacks might drive up the price of the token and like have like sort of like a treasury strategy to be like, okay, we've got, something that might, I guess the right way to use as a denominator would be something that's going to appreciate relative to the cost of API calls. So I think
Mhm.
it could produce like a whole, we've obviously seen treasury mania in Bitcoin and ETH as a hedge against the dollar. It'll be an interesting to see how people hoard network tokens as a way to like sort of like hedge against like their API costs or the chance of, hey, we made this tiny game and now we know if we do hyperscale, we're going to have the front end capital to be able to pay for those API calls.
Yeah, well, so two thoughts on that. So first of all, you're partly making the case for why stablecoin payments is important for pricing a lot of things in compute, because a lot of users will just want stablecoin payments without even thinking about any kind of token volatility, which certainly is a thing in crypto for sure. So that's an important part of the platform. The other piece, though, is yes, there probably are people who will sit on tokens and if they think that token value goes up as compute cost goes up, you could think of that as a hedge against compute cost. But that said, the very fact that there is a liquid asset class now around compute, it doesn't need to be the token itself that exists as that hedge because now you've got a market economy, which means that people could potentially create DeFi infrastructure around it. You could have options contracts, you could have hedging, you could have futures contracts. So in the energy markets, for example, a lot of companies such as airlines, for example, take out futures contracts to stabilize the cost of energy because otherwise a huge spike in energy costs could literally put them out of business. So with compute, you could potentially do the same thing where not only are you paying stablecoin, but now you've also got the ability to capture volatility countering hedges through the existence of financial markets. So that's why compute really needs to become a capital market as opposed to where it is now, because compute, like energy, is a huge part of our global economy, right? So it's just cloud services providers alone, it's hundreds of billions of dollars of cloud compute that's already happening that so many businesses are very, very dependent upon. Even in the game industry, like the one section which like that's our foothold to begin here. Game industry is 200 billion, and it looks to us that the average game company spends about 20% of their top line on infrastructure, cloud, the labor around it, code to help build their back end. Roblox is a good example of that. They spent like $1 billion last year on infrastructure. At one point, I think it was 40% of their top line. I think they eventually got it down into the 20%-ish range. But that just shows you, like, even in just one industry, how much is going to compute infrastructure. Now multiply that across everything in the world. And it's a huge amount of spend that is not slowing down anytime soon. And in fact, the lower the costs get for compute, the more the total pie actually will get because it unlocks so many other people who can enter the market and build applications that otherwise would not exist.
Yeah, I'm super excited about it. My brain, the financial part of my brain is spinning on soon there will be, sort of consulting companies specializing in this, trading companies, probably funds that spin up specializing on compute, just like another commodities company. But we are at the top of the hour, so I'm going to holster my Web3 based questions. I know you're cranking on a bunch of different stuff, so I will turn it over to you for final thoughts and we can wrap up.
Yeah, great conversation. We explored a lot. We started with games and we ended up in financial markets. So, I mean, I think the big thing to understand about us is our origin is in games, but there and that's going to continue to be like absolutely critical for us. It's a great domain for us to be in. There's so many more places you can go with this idea of capital markets. That's what the launch is that we're doing on November 6th, because we can really start to unlock a lot of value for more participants, people who want to add compute, people who want to have more reliability and price on compute. That's essentially what this network is about. And the token launch powers this whole network. So, love to bring in more people who are excited about this, whether you're a game developer, whether you're a compute supplier, whether you're someone who thinks you could use this compute network in some new way. Love to just engage with more and more people of the community and just come over to beamable.network, learn about what we're doing.
Love it. And we'll have a links down to Beamable's Twitter account, which you should be able to find everything else you need. But John, greatly appreciate your time. I always learn something from our conversations, many things usually. So really appreciate not only your time, but also you pushing the space forward.
Thanks, Nick. It was a lot of fun.
All right, take care, John. Best of luck with launch tomorrow.
Thank you.
And this has been Neo Tokyo's official podcast, Interlinked, and we'll be back with another episode next week. Take care, everyone.